Hello, can you hear me? Yes. Hello. Let's get started. So the iPhone was not the first smartphone. Java wasn't the first programming language. Linux wasn't the first operating system. And Google wasn't the first search engine. And arguably, Google wasn't first to functions as a service. Hi, my name is Alexis. I work at Google. It's great to be back in Antwerp, where the weather in November never disappoints. Welcome to this talk and to the thousands of people watching online. We'll talk about serverless compute options today in the context of Google Cloud, specifically Cloud Functions. I'll talk also about App Engine, which we define as being serverless, and I'll explain why. We'll also highlight a demo which I'll invite you to participate in, which is an app that's been built spanning across multiple serverless products that we have. So first of all, I'm sorry, I need to start with this. At least you'll see the perspective from which we're coming from. What is serverless? Well, obviously, there's no servers to manage. Of course, you have somewhere, and if you drill down, you'll find some servers somewhere. But really, it's an operational model. There are no servers to manage. That's really the important part. The second part is we, as a provider, will do our job to manage the server, and especially in terms of scaling your service to infinity and back to zero, and adjusting the resources that you need based on the load. And you will pay for the use that you have of the resources that we put together to serve your service. Second, it's a programming paradigm. And I like to break this down into two things. The operation model being one, the programming model being the second one. And this is where we talk about services. Hopefully you don't carry around large jar files which implement or an entire runtime, but instead you call services, and you've broken your applications into several services, maybe not microservices, maybe not hundreds of them, but at least you have clear responsibility in who's doing what, and you don't reinvent the wheel and use existing services. And the last one here is event-driven. What triggers a function or a service? It may be an HTTP call, but that's kind of a special case of an event that happens and that triggers that thing. It could be a file being uploaded to a bucket. It could be a message being posted to a pub/sub queue. It could be a lot of different things happening, generally speaking, in the system. It could be system-level things. It can be higher-level things in your app. And actually, serverless is a lot more than just functions as service. A lot of things where you don't have to manage those servers is probably serverless. If you're in the data warehouse business, you want to give your data and a query and get some response back. You don't really care about putting up a cluster, sizing it, and sizing the file system that you have underneath. You just want to give your data and a query and get some response back in a reasonable time. And there are a lot of other examples. Storage at a very basic level. You just want to store things in buckets and have access control list on each of those buckets and files. That's really all you want to do. But if we focus on the compute aspect, at least within Google Cloud, we have two options. One is Cloud Functions, and the second one is App Engine. And of course, Google Cloud nowadays is a lot bigger than just compute, and we have products to address many of the other things we consider serverless. But let's focus on compute, and let's focus specifically on those two. The first one, Cloud Functions, is obviously functions as a service, and the other one, App Engine, has been around for about 10 years, and for those of you that are old enough to remember, was defined as platform as a service, which may or may not resonate well with you today, but I'll cover these two. So why two? Let's find out. The great thing about having choice is that it enables you to adapt to different scenarios and different requirements. But of course, along the way, you have responsibility for making that right choice in the right circumstances. So let's start with functions. Typically, a function responds to an event, as I said, and that could be an HTTP call, but that could be many other things. And there's this little piece of code. Hopefully it's small enough that it fits on the screen. maybe 2. And it probably will invoke other services, other APIs that you have written or that you depend on. It's kind of a glue approach. And this is where you get into the cloud and you have access to typically the power of the platform that you're using. You get a response back, and then you format this in one way or another, and you send it back to whoever was making the call. Could be an end user, could be another service. The unit of deployment here, that's really a key thing, is a function. And we'll see that you can have different units of deployments. All right, let's look at a really simple hello world. This happens to be written in Node, which was the first language we started with. And typically, it fits into 3 lines, I guess. This is 3, 4 if you count, everything. And that's really all you need to do. Provide the code that's really simple, that needs to implement, in this case, a signature, which will have 2 parameters, the request and the response, set a status quote, and send a string back. This is your typical, simplest possible hello world in cloud functions. No additional requirements, no additional configuration. Once you deploy that, you get an HTTPS fully qualified URL. It scales, obviously, automatically. Not that this would need a lot of scaling and would be super useful. And you do have sub-second billing. And this was so small that I needed to add a screenshot to this. So let's actually see this in action and see if we can show you the power of this. And of course, I lost my window. Let me bring it back. Sorry. So let me make this thing bigger. Let me create a function. Maybe bump up the font a little bit. All right, let me call this function, well, Devoxx sounds like a good name. You can allocate different amounts of memory. Let's stick to the default. The trigger, in this case, is HTTP, but there are lots of different events. There are a lot more coming, but these are the ones that we currently have. Since this is HTTP, this is the URL that you'll be able to call your function with. You can provide the code here inline. You can provide it as part of a zip. You can send it to cloud storage, or you can use one of the hosted repositories that we provide, the Git repos that you have as part of a project on GCP. And here's the hello world. And you may want to change a few things just to see that it's real, and call it Devoxx. At that point, this is the method we want to invoke, so hello world. And there are a few options that you can add. Typically, what region do you want to deploy to? The nice thing here is that you can deploy to multiple regions. And in a given project, you can have multiple functions deployed across multiple regions. And we'll get back to environment variables just a bit later. So typically, at that point, we are provisioning a function that will be running. In this case, I should have chosen Europe, since we have that as a choice. In the US, the runtime is this. We have Node 8 as well in beta, and a few others that I'll talk about later. And eventually, you're actually, that's it, it was deployed. If I click on it, you'll be able to see that not only is it live, but you have a number of services that we offer for you to manage this. So obviously, it was never invoked, but you could see the memory usage, again, never invoked, so you don't see anything at this point. So how about we invoke this? We could just hit the URL and hello Devoxx. Okay, so that was very unimpressive. But at the same time, a lot of things happened on the cover. These things have to do with the fact that we have the ability to test this. So there's no input specifically. The event is just the fact that we call this URL. There's no payload, but we could still, do the same invocation. There's some instrumentation that happened, which hopefully at some point means that we'll get some graphs here. This is when it was last deployed, and where it is, and what are its attributes. And of course, you can go and look at the source. If you were to have some dependencies, these would be provided here in a pretty idiomatic way for Node developers, which is a packend.json config file. All those dependencies would be resolved on the server, which means that if you have anything that's native, we will go and get the right ones for the platform that we manage. So that was a really quick look at a very basic function. Let's go back to slides for a second. So really, a function, if it was to provide any value, it's the value that it has in the way it gives you an access to cloud services. Once you're running this, which as you see is really easy, it's just pushing a bit of code, you have access to a lot of services. In the case of Google Cloud, we have storage services, analytics services, machine learning services. We have a number of things, storage obviously. And really, all you have to do is write that little function and you're able to call any of these. You're authenticated and you're able to do all of this without any boilerplate code. Today, we are generally available, which in Google Cloud terms means we offer an SLA, a service level agreement, which means that we guarantee that you'll have 99.5 availability. We have multiple regions, as I mentioned, and we can deploy in a given project apps and functions, to those different regions. We have fairly modern runtimes, but we're working on more modern ones. We're working on newer versions of Node. We're trying to catch up and follow Python as well. And we obviously have more languages coming soon. Go is currently in alpha, and you can guess what kind of other languages we're working on. But at this point, I don't have any timeline to share with you. What's common across all of these, and you'll see that it's common across all of the serverless offering that we have to offer, is the ability that we provide to have everything monitored and instrumented. Stackdriver is the technology that we use, is a set of tools that we have, and I have a talk on this tomorrow, when it comes to logging, to error reporting, to traces, to debugging live production code. And this is done because we're a fairly opinionated platform in terms of the things that we expose, the data that we expose, and that is being collected and made available through these different tools. There are a few advanced features that either are available now or will be very soon. Actually, they start with the right-hand side. The environment variables are, as you would imagine, a variable that you pass at deploy time, and that you're able to grab from your code in a very idiomatic way, an environment variable, and that can set a lot of different things. Maybe if it's not a secret, it's something that configures your app. It's something typically that doesn't live in your code, and you can change at deploy time. Cloud Connect is our, Cloud SQL is our managed SQL, both Postgres and MySQL databases. Typically, you used to go out through the internet when you were making calls from a function to Cloud SQL. You no longer have to do this, which obviously improves performance and reliability. The scaling controls are interesting in the fact that functions will scale. I don't really see a problem with scaling most of the functions that people are writing today. The thing is, those functions might be calling something else down the road and have a dependency on a system that may not scale just as well. So this is where you're able to provide a maximum number of concurrent calls that are being made to a given function, just because the backend service, in this case, is something you want to protect. And finally, VPC and VPN is the ability for you to have a function that is part of a network on cloud platform where virtual machines live. Maybe a Kubernetes cluster, maybe just a plain virtual machine. And this is something you may want to call and interact with from your function. And this is something that's being currently rolled out. All right, let's switch gears. Remember I said the unit of deployment is a function. This was Cloud Functions, obviously. Well, App Engine, you guessed it, the unit of deployment is an application, because not everything can be defined as a set of really small functions. Maybe an application has different services, different modules, they have dependencies, maybe they're written in different languages, they have versions. There are a lot of things that can make an application, a real-life application, require a unit of deployment that's somewhat more coarse-grained. So we believe this is really useful for existing applications that you may want to move to the cloud, and I'll explain why that is true and why that is true more today than it used to be with App Engine, and probably for applications that have an HTTP front end. We have support for a number of languages, more than we have for functions. We're catching up, and I'll tell you what the plan is there. No config, maybe just really simple configs, like maybe if you're in Java, an XML file to explain the concurrency that you would like to have, but it's really minimal. And of course, it auto-scales. That's the point. And you only pay for when your code runs. So you do have scale to 0 with App Engine, which is one of the criteria, I guess, for serverless. So currently, we have Java 8 support working on Java 11. We have Node 8, we have Node 10 in beta, we have Python, PHP, Go, and all of these are being evolved much quicker than we used to. And I'll get in the next slide to why that is. We have a new instance scheduler, which will spin up instances in the auto-scaling process much faster, and at the same time, we will scale down more effectively, which in return will give you better economics for the runtime. Faster deployments, HIPAA is healthcare in the US. Now, why is this important and why are we deploying much faster new versions of new languages, new runtimes as we call them, is because we've worked for the last few years on a new runtime, a new stack, which we share across functions and App Engine. We call it second generation, but the name doesn't really matter. It's not all that good anyway. But what's important is that it's based on a project called gvisor, which was recently open sourced, and which is how we implement a sandbox in the environment that we run on. Typically, the requests you have on App Engine are requests that run right next to a Google search, a Google Maps request, a Gmail thread. And typically, we want the sandbox to be efficient, and that's what gvisor provides us. One of the effects, I would say side effects, but not really, because this is really important for us, was to be able to enable idiomatic dev experiences. I don't want, as a Java developer, to be using specific APIs that work only in the context of App Engine. I want to be using any APIs. If I want to shoot myself in the foot and call system exit, that's fine. You can do that. So we actually no longer have a wide list of classes that you can use in App Engine and those that you cannot, and other APIs that you should be using instead. We support also native modules. And again, in the case of functions, we will resolve those dependencies at deploy time, and we will download them ourselves because we know what platform we're running on. And of course, we worked a lot on performance, so hopefully this all executes faster. One thing that has not changed in App Engine is the ability, as I said, to have multiple services that make up an application. Each of those services might have multiple versions, all active at the same time. And each of these versions can be scaled independently because maybe one module is an admin module, which doesn't need a whole lot of resources. Whereas your front end, which is serving customers, might need a whole lot more. So this is really key for enabling a number of scenarios where you have blue-green deployments, A/B testing, where you're able to deploy to production without promoting a given build, and only do this after the fact. And of course, roll back mistakes that you might have made. And one of the things that we have to offer here is something called traffic splitting. So typically, you have multiple versions deployed, and you can direct the traffic from one to the other or across multiple ones. Maybe you'd like to implement A/B testing and offer 10% off to some customers and free shipping to the others and see what works best. Maybe you just want to do canary deployments, have this deployment of this new version and send 1% of the traffic to this thing and see, looking at the logs of only that version, how things are going, and progressively ramp up from 1% to 5 to 10, eventually get to 100% if all goes well. Or go back. Typically, this is what traffic splitting as an underlying tool helps you achieve. We also have a bunch of external services, which are neither functions nor app engine. These are things that live on their own and that offer something that really couldn't be just features of one or the other. One of them is cloud tasks. Typically, you have timeouts when you're a user or you're invoking a function. Different providers have different timeouts, and it's in the order of minutes. But you might have tasks that need to run for longer than that. And typically, what we have to offer here is something called cloud task, where you can post a job and get a response back and be notified when the job has completed. And typically, don't do this on the caller user thread. It's a great way, it's a great pattern to decouple what should be interactive and real time, as we'd like to say, versus something that should be offloaded to a task. Cloud Scheduler is something that we've recently announced that's been available as part of a feature of App Engine, but now it's a standalone feature. And it's really cron as a service. It might seem silly, but it's super useful if you want to schedule calls to functions, if you'd like to do things on a repetitive basis, and do this all in a centralized manner, and do this in an approach where everything is run in the cloud. So it's highly reliable as well. PubSub is really a product of its own. But it's a great way to implement different patterns of services calling one another, or an architecture of services. And it's the ability to post messages to queues and topics and to consume them on the other end. And that's been very effective for a number of our customers that have been using functions and App Engine in collaboration. All right, let's finish with a demo in the 9 minutes that we have left. If you have a phone, you can go to this URL, or if you have a laptop, that might not work just as well, but we can try. This is a photo sharing app, fairly basic, one where it's a progressive web app. That was built by my colleague Guillaume and a few other colleagues for a presentation we did recently. And the ability here is to just post a photo, to have one of our machine learning APIs, the Vision API, look at the photo and see what kind of attributes it sees there, attach those to the photo and use them as tags. And then, because this is user-generated content and I can't trust all of you with this, we also go through is this a safe photo filter? And we have an admin module that will actually look at it and give the admin the opportunity to discard things that you've uploaded that were not appropriate. Basically, I'm taking photos. It's returning attributes. We're calculating the most popular tags for all of those photos. And I have my admin view, which lets me either publish or discard stuff that has initially at least been flagged as problematic. So the architecture is fairly simple. The user-facing part is implemented in App Engine. This is the web front end. We upload pictures to a bucket, which triggers and will compute metadata. With the upload to the bucket will trigger a call to a function, which will make the call to the Vision API. So very basic, here's the photo, what you see, get some JSON back, and out of this, write this in the data store persistent module that we have. And I do have the ability, because this is kind of a time-consuming compute task, to, on a regular basis, with a Cloud Scheduler, recompute the entire set of tags and how frequent they appear. And I also have an admin module, which in this case is written in Go, the rest is written in Java, and the function is written in Node, to, again, look at what's been uploaded and play my admin role. So it's one app, multiple functions, one App Engine app with multiple services, different languages, and a bunch of services that are being used. And this is fully serverless. No server was harmed in this demo. So let's look at it. that's not it. This is it. So let's see, have people been, yep, oh, somebody's looking. I know this guy. Okay, so somebody's having some tea, some badges. Okay, so it looks like this is working. People are actually, this is Guillaume, my colleague. This is me. Thank you. So this seems to be working. For every single picture, you can see that we have tags. So typically, this is a plush, some material, textile, and so forth. So we can go to tags and see all the most popular ones. And if we click on one of them, say, I don't know, food, we can see probably all the food, or kinda, that Guillaume has been having recently. So here are a few things. So that's the app. Now, we do also have this admin feature. People keep on posting. This is good. Thanks. Hope this was good. The admin part will let you see what has been filtered, and some of it, might be per American style or standards, I should say. Some might be considered medical, or it could be violent. I don't know. Is this violent? Anyways, you get the point. Some of it might actually be true, but if you have user-generated content, you owe it to yourself to actually, check everything that's being uploaded. And you do either this manually, or you have an API like this one to do it. So one quick thing I want to show you, since the front end is written in App Engine, we have this feature called traffic splitting, which I briefly mentioned. And I could say here that I would like to split the traffic that is currently all going to one version of the app, called current, and send some of it, not to bogus, that's tomorrow's demo, but to Coral, and say that this needs to be at least 73%. And by IP address, that's not ideal, because we probably might all be going through the same one, so let me cancel that, and let me say it's completely random, and I want Coral to be there, and bump it up to, all right, 67 sounds good. So now typically, both of these app versions are running. And let me check here on my phone. Hopefully at some point, we should have at least some of you, if we refresh this, have a different background color. That's as inventive as we were. And indeed, you have something called Coral here. This isn't the most pretty thing, so maybe we just go back and typically remove that and save. And voila, we're back to having 100% being served by this one instance, this one version that we had. Okay, so that was the quick demo. Let me just close by showing you, giving you a glimpse at what we're working on. I'll skip over that. Typically, we have logs. We can filter by versions, by artifacts that are being deployed. We have error reporting, which is really cool. Typically, you're notified, and we sum up an error. So we don't show you all of them. We just show you one type and how often it has occurred. But how many people here are familiar with Docker? Yeah, I would expect that. Most people here, right? So maybe you want to deploy a function or an app, and we can take that. That's fine. We know how to handle that. I just covered that. What if you wanted to give me a container and have it run serverlessly, which is from 0 to whatever resources we need to run this, and pay for what you use? Well, that's what we're working on, actually in two different approaches. One is the same way you deploy an artifact, which happens to be a piece of code, which is my function. You might want to give me a Docker image, in which case we have something called containers on Cloud Functions. So just deploy. Instead of code, you just give me a container, and we will scale it from 0 to whatever needs to be there. And that's something that's currently in early access, in an early access program. Here's a short URL if you'd like to try this out. The other approach is, well, a lot of you have invested in Kubernetes, whether it's on-premises, on Google Cloud with Container Engine, or elsewhere. What we have to offer for Kubernetes Engine on Google Cloud Platform is something we call the Serverless add-on, which is built on Knative. So if any of you were in the session earlier today by my colleague Ray, you've heard of this. This is how you implement and you provide an abstraction layer on top of Kubernetes to provide a serverless environment. Again, This is in early access program. And with that, I guess I am out of time. I actually have 30 seconds, but if you have questions, please come to me. Thank you for your attention, and I have another session tomorrow that will focus on the DevOps aspects of serverless. With that, thank you very much.